This video is for problem 396, number 49, and the review for chapter 5. It's from topic 10.1, solving trigonometric equations. And there's no interval specified, which means that we need to find the general solution. And the problem given is sine of x minus tangent of x is equal to 0. Well, right away, it doesn't look like anything we can do with that. There's no identities that address that. It's not a Pythagorean identity. So let's try turning everything into sines and cosines and see what that gets us. So we have sine of x minus sine of x over cosine of x is equal to 0. And if we get a common denominator for the sine of x term, then we'll get sine of x cosine of x over cosine of x minus sine of x over cosine of x is equal to 0. And of course now we can combine the two parts, and we get sine of x cosine of x minus sine of x all over cosine of x is equal to 0. Now at this point we need to stop and think about what this means, having a cosine of x in our denominator, is that we can't have any solutions where cosine of x is equal to 0. Okay? We can't wind up with that as an answer because that would be undefined. So let's see where we get to, but keep that in mind. So now we can go back and factor out sine of x cosine of x minus 1 all over cosine of x is equal to 0. Okay, now we have two factors in the numerator. Since cosine of x varies between -1 and 1, there's nothing that can happen in the denominator that'll make this equation true. So really all we have to look for is when the numerator becomes 0. So let's solve that. That's at sine of x equals 0 and cosine of x is equal to 1. Those are the two solutions that we have. Well, sine of x equals 0, that's the inverse sine of sine of x is equal to the inverse sine of 0. So that says x is equal to the inverse sine of 0. And that happens at two places. It happens when x is equal to 0 and x is equal to pi. Okay? But remember, we have to find the general solution. So we have 0 plus 2n pi, and we have pi plus 2n pi. But what that means is we have answers at 0, pi, 2 pi, 3 pi. So we can actually write this part as just n pi, because all multiples of pi are a solution for this. Cosine x equals 1, well, that happens at one place. That's when cosine inverse cosine x is equal to the cosine inverse of 1. So x is equal to the inverse cosine of 1. So that says x is equal to 0. General solution, so we have 2n pi. But notice that this is contained in these solutions. So the cosine x equals 1 doesn't give us any more solutions than we already have within pi. So our final answer for this one is just n pi.